Hi, glad you could join us at Couchbase Connect Online 2020. I'm Priya Rajgopal, Principal Product Manager at Couchbase, responsible for the Couchbase Lite and Sync Gateway products. In this session, I'll be providing a technical overview of the InterSync Gateway replication technology. I'll be kicking things off with a discussion of related use cases. For the benefit of those who are new to Couchbase or Sync Gateway, I'll provide a technical overview of Sync Gateway as well. This would provide the relevant context as I dive deeper into the InterSync Gateway replication technology. I'll provide a demonstration of some of the new capabilities of this replication technology, so you'll know what you need to do to configure this within your own environment. And then I'll finally wrap things up, leaving you with some helpful resources. So let's get started with some use cases. In recent years, there's seen a growth in this new paradigm of computing referred to as edge computing, which is a distributed computing framework that aims to bring data storage and processing closer to the applications that generate it and use it. So the edge, as we define it in the context of edge computing, is where data storage and processing happens. So this could be a standalone device, it could be an edge device such as laptops, smartphones, tablets, etc., or it could be an aggregation point, a gateway in a micro data center. Now, micro data centers are similar to cloud data centers in functionality, but they are smaller footprint, but they are also on the same local area network as the applications or clients that use it. So applications, examples could be servers in an IT closet of a retail store, cruise line, hospitals, etc. So in the context of the session today, the edge is going to refer to a micro data center. So what kind of applications are we talking about here? The kind of applications that need this kind of capability are business critical or mission critical applications that need to be resilient to network disruptions. So apps that can provide 100% guarantees on availability. So business uptime is critical. Applications that are required to be responsive in real time or near real time. Applications that have stringent requirements on data governance and privacy. I mean, these are applications in the consumer space, in the healthcare sector or finance space. Are applications that generate a lot of data, like the industrial IoT applications, ML, AI, ML apps. So transferring all that data, which is potentially ephemeral, to the internet, to the cloud data centers for processing can impose a significant cost on network bandwidth and on server load. So by locally processing a lot of the data, the sensor data that's generated by these applications, you save on network bandwidth usage and also the cost by locally processing the data. So how does cloud to edge sync fit in? Now, when we talk about edge computing architecture, you're essentially talking about a distributed computing architecture where you've got cloud data center and number of edge data centers. Now, the edges are kept in sync with the cloud data center, which is sort of like the mothership. Now, the edges are capable of operating autonomously in a completely disconnected mode, even when there is no network connectivity, or if the network connectivity to the cloud backend is temporarily down. Here are some common examples. Large retail outlets, they'll continue to service their customers even in case of network outages. So business downtime is not only detrimental to customer experience, it can have long-standing impact on the reputation as well. Passengers on a cruise ship can take advantages of all the onboard services right there from their mobile applications, even if the cruise ship has got no satellite connectivity back to the cloud backend. And this could be in the order of days or months, depending on the length of the voyage. Similarly, hospitals or healthcare facilities can process patient information locally and provide real-time responses. In the industrial IoT case, which I talked about just a few minutes ago, sensor data from equipment in a manufacturing center or factory is locally processed at the factory data centers and can immediately react to any deviation from the baseline. And only aggregated data is sent over to the cloud remote data centers where it is persisted for a longer period of time. Now, before we dive into InterSync Gateway Replication Protocol, a quick primer on Sync Gateway. Here's a quick overview of the Couchbase stack. You've got Couchbase Server, which is our flagship NoSQL data platform with support for a number of services, including query, analytics, full text search, eventing, etc. Typically, you'll develop a web backend application in your language of choice using one of our many server SDKs that allow your backend application to interact and access data from Couchbase Server. Then you've got Couchbase Lite, which is fully featured NoSQL embedded data storage for mobile and non-mobile embedded platforms. Now, Couchbase Sync Gateway sits in between. It's the middle tier, and it's responsible for secure data sync, routing, and access control between between the client tiers and between the server tiers. A key characteristic of this architecture is that you can deploy this in the cloud or in the edge data center. You have complete control over where you deploy Couchbase Server and Sync Gateway. And this is an important requirement when it comes to deployment of edge computing applications. A quick peek at the core functions of Sync Gateway. First and foremost, it's sync. Sync from cloud to the edge. The edge could be Couchbase Lite enabled device, right? So it could be an edge device, or it could be another Sync Gateway. And this Sync Gateway could be deployed in an edge data center. Fine-grained access control to restrict any unauthorized access to data. Something that was not very obvious in the previous component architecture slide is that in addition to supporting replication with Couchbase Lite enabled clients, is that the Sync Gateway also exposes a RESTful interface that other web-based client apps can use for connecting to Sync Gateway. Finally, end-to-end security. Got TLS, all the data and all the communication is encrypted using TLS. The focus of our talk today is InterSync Gateway replication, which is replication or syncing data from one Sync Gateway in one cluster to a Sync Gateway in another cluster, remote cluster. Sync Gateway offers a range of flexible deployment options. You can deploy it on bare metal, you can deploy it in a virtualized environment, or you can deploy Docker images in a containerized environment. You can further use an orchestration engine such as Kubernetes for managing these containers. Now, this flexibility when it comes to deployment is an important consideration as the requirements of edge data centers vary significantly depending on the application. The management of, especially as the number of edge data centers grows, the management of these distributed edge data centers is a key consideration in edge computing architectures. So technologies such as Kubernetes is gaining a lot of traction. Now, Couchbase Server and Sync Gateway, they are well poised for such deployments with a Couchbase Autonomous Operator, which makes it very easy to orchestrate the deployment, provisioning, and administration of Couchbase Server instances. I just scratched the surface in terms of what you can do with Sync Gateway. For more information, here are some related sessions at Connect Online 2020. We've got a beginner's track with Couchbase for mobile, and then there is an advanced session on Sync Gateway. And if this concept of edge computing was interesting, we have a dedicated session which talks more about edge computing, the value proposition, etc. So now let's look at InterSync Gateway replication. Consider a typical deployment. You've got Sync Gateway with Couchbase Server and a number of Couchbase Lite clients. Sync Gateway is configured with a JavaScript function where you specify the access control policies. Right? This defines the access control policies defines who has read or write access to data. Now, with the Sync Gateway, you can actually control, something to bear in mind is that the access control policies that are applied on the Sync Gateway, it applies regardless of whether you're syncing to a Couchbase Lite enabled clients or whether you are syncing to another Sync Gateway in a remote cluster. Now, where do you deploy this? You can deploy this in a cloud data center, or you can deploy this in an edge data center. But the key thing is that you need a way for the data to securely sync between the cloud and edge data centers. So something which is important to understand in the concept of edge computing is that edge computing complements cloud computing architectures. So generally, you are processing and storing and processing some data at the edge, but eventually that data does get aggregated and gets persisted in the cloud for longer term analytics and an aggregated global view across all the edge centers. And this is where InterSync Gateway Replication fits in. This technology allows sync between cloud and edge data centers. And this sync is bidirectional, it's secure, and it is highly scalable. You can scale to tens or hundreds or even thousands of edge data centers. I want to dive deeper into access control model in Sync Gateway. This is very critical because a fine-grained access control is a critical component of any sync technology. Now again, the access control model is same regardless of the sync technology that's in place, whether the sync gateway is syncing to a Couchbase Lite enabled client or if it is syncing to another sync gateway. Now, every document write that is processed by the sync gateway is assigned to a channel. Think of a channel as a tag, and it's sort of the centerpiece of our access control model within the sync gateway. A user is granted access to a channel, and by virtue of access to a channel has access to all the documents in the channel. In addition, there is a concept of sync gateway roles. This is sort of a way of grouping together users with similar characteristics. A role can be granted access to a channel and documents in the channel, and a user can be assigned to a role. And so by having access, being assigned to a role, they have access to the channels that a role is granted access to. So how does this model fit in with the cloud to edge sync paradigm? The edge, we're talking about user, but what is a sync gateway user? It really varies depending on application. It can, for a consumer-facing application where an edge could be an edge device, a user could be an individual consumer. But when it comes to an edge data center, an edge could be, or a sync gateway user could be, say, a hospital, or it could be a factory ID, or it could be a store ID. The edge is essentially the sync gateway user. So consider three channels: a private channel for edge 1, a private channel for edge 2, and a channel that is shared by edge 1 and edge 2. Documents exclusively intended for edge 1 are assigned to edge 1's channel. Documents exclusively intended for edge 2 are assigned to edge 2's channel. And documents that have to be shared by edge 1 and edge 2 are in the shared channel. You assign edge 1 to channels for edge 1 and edge 2 to the channels for edge 2. And of course, edge 1 and edge 2 are assigned to the shared channel. As I mentioned again, so what is the edge? The edge really depends, the definition of the edge depends on the application. So what is InterSync Gateway Replication? So once again, it allows for secure, resilient, scalable, bidirectional sync of data between cloud data centers and between the cloud and edge data centers. Sometimes referred to as SG Replicate for short. So those who are familiar with Sync Gateway, or if you've been using Couchbase for a while, are probably familiar with SG Replicate. The new version that is introduced in 2.8 replaces the current version of the SG Replicate protocol. Now, when you're talking about enterprise-grade sync technology, there are several considerations. And let's look at how the new sync technology that's introduced in 2.8 stacks up. When it comes to scalability, the technology can scale easily to tens of hundreds of thousands of edges. You've got end-to-end security with fine-grained access control. So read access is at the granularity of a document, and write access is at a granularity of a property within the document. The protocol is resilient to network disruptions. So the protocol implements an exponential backoff retry algorithm, and the backoff period is configurable. To optimize network bandwidth usage and to reduce transfer costs, the protocol supports delta sync. Delta sync is the ability to sync just parts of the document that have changed. In addition, sync can operate in both continuous or one-shot or on-demand mode. So apps are in full control over what to sync when. So applications can choose to sync data during off-peak hours, can do their maintenance and sync maintenance the data during off-peak hours, you know, at 12 p.m. or 12 a.m. Over a weekend, for instance. The solution supports comprehensive conflict resolution strategy. In a distributed environment, you've got multiple edges and they are potentially updating the document at the same time. Conflicts are bound to happen. Sync Gateway provides automatic conflict resolution support. In addition to automatically picking a winner among the conflicting documents, conflicting revisions using predefined set of heuristics, there are out-of-box resolvers that are available. But if those don't work, applications can have full control over how the conflicts are resolved by defining their own conflict resolver. And how is this done? It's very, very simple, similar to the way the sync function is defined, which is the JavaScript function where you define your access control policies. You define a JavaScript function as part of the sync gateway config. And this is your conflict resolver. Now, as you shall see, it takes just a few lines of code, a few lines of configuration to enable sync. We also have a dedicated REST endpoint that allows you to remotely administer, manage replications. So this is in addition to your standard configuration file where you can configure your replications. There is a REST endpoint that allows you to create, stop, restart, monitor your replications. Although the examples typically show a two-tier architecture where you've got a cloud tier and you've got the edge data centers, you can have a hierarchy, right? I mean, you can have a cloud data center and then you've got your regional data centers and then you've got your other downstream edge data centers, right? So you can have a hierarchy. There are several tiers deep. This is a typical deployment of an edge computing architecture with sync gateway and the intersync gateway replication. And now we'll look at a demo and concept walkthrough. So now I'll demonstrate some of the capabilities of the new sync technology. This is my demo setup. I've got two clusters, one running on my laptop and one running on the remote cloud. The laptop cluster represents the edge data center and the remote cluster represents the cloud data center. The local cluster that's running on my laptop includes a Couchbase server node and two sync gateway nodes. On the remote side, I've deployed a cluster on GKE using Kubernetes. That cluster includes three Couchbase server nodes and two sync gateway nodes. If you consider a retail store application, the laptop simulates a retail store outlet and the cloud cluster simulates a regional data center. Typically, you'll have hundreds of these edges corresponding to retail outlets. In my case, we have one store that's represented by my laptop. The cloud server, the Couchbase server that's running on the cloud has a single bucket called stores that's got data corresponding to all the stores. The local Couchbase server instance that's running on my laptop has a store local bucket that has store specific data. Now, there are two replications that are configured on the sync gateway nodes that are running on my laptop, on my local cluster. While it's not required, it is generally recommended that you choose one of the replicating endpoints as your active side of your replication. The active side is the side on which the replications are initialized or configured. The directionality of the replications don't matter. Yeah, in my case, I've got a push-pull replication, a bidirectional replication on the products and orders data. And then I have a unidirectional pull-only replication on the common channel or common data. And both these replications are configured on my local laptop. So this is recommended just because it makes it simpler for debugging, troubleshooting, maintenance purposes. So whenever you're configuring your system for intersync gateway replication, pick one side as the active side of your replication and configure those replications there. Now, before we actually go into the demo, I'd like to talk a little bit about how the data is segregated. So the documents in the stores bucket in the cloud are segregated into store-specific products channel and store-specific orders channel, and this segregation is based on certain attributes in the document. Likewise, there is a common channel which holds documents that is common, that's not products related or orders related, and it's common to all the stores. Now, in my case, I have a single store, store 1, that's represented by my laptop. It has access to store-specific products channel and store-specific orders channel, and it's got access to the common channel. Now, in an actual real-world application, you could have any number of these stores, and each of these stores would have access to their private product channel, to their private orders channel, and to the common channel. In other words, the products and orders data are store-specific, and then the rest of them, for example, user profile information, that could be the common data that's shared across all stores. So now let's get to the demo. So just to level set where we are, this is my local environment. I've got two sync gateway nodes running on my laptop, and I've got one Couchbase server node. Notice that in addition, I've also got Prometheus and Grafana running on my local laptop. Prometheus is an open source monitoring framework, and Grafana is an open source data visualization framework. Now, introduced in developer preview mode in Sync Gateway 2.8 is a new metrics endpoint that exports stats in Prometheus compatible format. In other words, you can directly monitor Sync Gateway nodes using Prometheus right out of the box. So in fact, I have a Prometheus instance running, and I've got Grafana dashboard going, and I'm monitoring both the Sync Gateway nodes. So there's nothing exciting going on right now because there's no data really being transferred, but as data gets transferred, we can use this for monitoring purposes. Now, this is on the remote side. I'm going to quickly make sure that everything is good. Yeah, everything is still up and running. I've got my 3-node Couchbase server cluster and 2 Sync Gateway nodes, which are running on the remote side. I've also got port forwarding enabled to the remote cluster, so I can actually access the admin UI on the remote cluster as well. Again, this is my local cluster. There's a single bucket called store local, which has store specific data. Right now, this is an empty bucket. I mean, you see some items, but that's not data. These are some system level meta information. That's sync metadata that's included by the sync gateway. But this is it doesn't include any data as yet. And then on the server side, we've got, on the cloud side, sorry, the server includes a stores bucket, and it's got around 80,000 documents. So let's explore the documents a little bit. I happen to know, okay, there's an orders document. Let's look at the metadata. This is the sync metadata, which is the sync gateway as part of the import process decorates these documents with sync metadata, which allows it to synchronize this data to all the replicate it to all the other clients. So in this case, we see that this document has been assigned to the orders channel corresponding to store 1. Similarly, if I were to pick a product document and you examine the metadata, you'd see that this is assigned to a products channel corresponding to store 1. And just to show that there is documents corresponding to other stores as well over here, right? So this is data corresponding to all stores, but I'll only be syncing down data specific to store 1. Okay, so before we start the right, let's examine the configuration file. So you have two options. In 2.8, you have two options by which you can actually configure these replications. The first option is to do it via the sync gateway config file. So the sync gateway config file is a JSON file where you specify the sync gateway configuration that is used during startup. And this is where you can configure the replications. But in addition, there is a new REST endpoint, a replication REST endpoint that's introduced in 2.8, which you can use for actually configuring these replications through a RESTful interface. But for our demo, I'm going to configure these replications to the REST endpoint. So everything over here, we are not going to go into the details of this config. It's all standard stuff. If you're familiar with Sync Gateway, or most of this should seem very familiar to you. So key thing is, if you scroll down to the databases section, there is a single store local data that includes configuration corresponding to this particular database. And just for the purposes of demo, I've got a user called store1. Clearly, in a production environment, you do not have to statically configure this user. You'll probably use the admin REST endpoint or OIDC for authenticating and creating these users. In any case, right now I've got a store1 user, and that store1 has access to store1's product channel, store1's auto channel, and it has access to the common channel. But the key thing really is from line 54 onwards. So notice that on line 54, I've got a configuration flag which says SG replicate enabled is true. In fact, this is the default value of the flag. Just note that for the purposes of demo, I have included some configuration options with their default values, just so you know what options are available to you as a user. But really, in an application, you do not have to include these config values if you're going with the default. So your configuration is going to be much, much smaller for a typical application. So in any case, over here, what this means is what this flag indicates is that this node, this sync gateway node, has to participate in replication. By default, all the sync gateway nodes, in my case, there are two sync gateway nodes, will participate in replication, but you have an option of opting out of participating in a replication. So over here, if I have two sync gateway nodes and I have two replications, the two replications are going to be configured across, uniformly distributed across the two sync gateway nodes. But if I opted one of the sync gateway nodes from participating, then you would have all the, you would have, in my case, in my example, you would have both the replications configured on one sync gateway node. Over here, as I mentioned, I've got two replications. One is a push-pull bidirectional replication, and this is the name of the replication. This is the replication ID. This is the conflict resolution type. I have a custom conflict resolver associated with this replication. I'm not going to, and you can define the conflict resolver as a JavaScript function right here within the sync gateway config. So it's extremely simple for anyone to configure a custom conflict resolver. So anytime there is a conflict that's encountered by the sync gateway, it is going to call into this function with this conflict object, which includes the local document and the remote document, the two documents that are in conflict. You have access to the full the meta information as well as the body of the documents, and you can choose to merge the documents in any way that's applicable to your application. And of course, you don't have to stick with one conflict resolver. You can choose to use the default policy, you can use one of the out-of-box available resolvers, or you can use your custom resolver. So you have a lot of flexibility in terms of how you can resolve conflicts in this mode. So again, I'm not going to go into the details. The key thing to remember is that you will have access to the conflicting versions of the document. Scrolling down let me bring up annotations. It's a little simpler. So here, line 84, we've got directionality, that's push and pull. So the replication protocol is WebSockets based, which means you have truly bidirectional full duplex communication. So you can have push and pull over the same replicator. So if you want to have bidirectional, you'd no longer have to have two separate replications, one for push and one for pull. And then you can specify line 86, you specify the remote endpoint that you need to replicate with. And then 87 and 88 is the username and of course the password, the credentials with which the replicating user's credentials. In this case, it is store1. And then 89 through 92, this is where you specify the filters on your replication. So remember, my bidirectional replication, I want to have it on the store specific products channel and orders channel. And this is how I have to specify that. In line 93, I've enabled Delta Sync in my demo. By default, it is false, so Delta Sync is disabled, but I've enabled Delta Sync. This is all that is needed in order to enable Delta Sync. Of course, you've also got to enable Delta Sync at the database layer, but then this is all that is needed to enable Delta Sync, which makes it very convenient. So as an application developer, you do not have to change your access patterns or change the way your data is modeled to enable or leverage this capability. The batch size is some tunable option that's available to specify the size of the documents, the batch size of data that is synced. 95, line 95, this is the mode of replication. Over here, I'm saying that this is continuous replication, which happens to be the default option, which means the replication changes are replicated in real time. And then something of interest should be line 96. That's the initial state of the replication. This defines the initial state of the replication when it is configured or initialized on a sync gateway node. By default, the initial state of a replication is running, which means if I have a replication that's configured on the sync gateway and I have not specified on the initial state, the replication is going to automatically start. I can override that default behavior with this flag, which says that keep it in stop, launch it in stop state. As a user, I will start it at the appropriate time, after the sync gateway is up and running. So very straightforward to enable replication. Notice that a lot of these options over here are default. So really it's just a few lines of code to have replication going. And then line 98, I've got my second replicator. It's a pull-only replicator. Directionality is pull, which says it's one directional. And over here, I'm using a conflict resolver type of remote wins. This is an out-of-box resolver. There are two of them that are available where you automatically, where you specify the system always picks the remote as the winner or the local as the winner. There's a local wins and there's a remote wins. And then you can specify the remote endpoint, and then the filter options over here. The filter options is the common channel. So the data that's in the common channel is replicated over this replicator. And then again, I'm enabling Delta Sync, and the rest of the options are the same as the previous case. So very, very straightforward to enable replication. It's literally 5 configuration options. The local, you at the very least have to just specify the remote endpoint, and that's it. The user, replicating user credentials, and the remote endpoint. And with just that, you'll be able to set up replication. So right now, let's, I've got, sorry, let me get some of these things out of my way so things are clearer. So I have, as I mentioned, there is a new RESTful endpoint called the Replication Endpoint that allows you to remotely administer and manage your replications through a RESTful interface. So this is going to be very convenient. Now, what I showed you was configuring the replication through the JSON file, the sync gateway JSON file. You do not have to do that. You would be able to create a replication, create a replication right here through the REST endpoint. You specify the body, exactly the same configuration as the previous case. So I can just use this and create a replication. And regardless of whether the replication is created through the REST endpoint or whether it is created through the config, those replications are persisted and they will survive restarts. So you do not have to worry about having to create the replications every time. You create it, it's going to be persisted, it's going to survive restart. So again, it depends on what suits your application needs, but you have this option of doing it through the RESTful endpoint. So at this point, right now, I'm going to quickly, I've got two sync gateway nodes, and for convenience, I've split up the APIs, by sync gateway 1 and sync gateway 2. So very quickly, let's look at the replications that are configured on sync gateway 1. So there are two replications. The first one, that's the pull-only replication. It is configured it's scheduled on sync gateway 1. This indicates the assigned node. The target state is stopped. And then remember, I've got another push-pull replication, and that replication is automatically distributed and assigned to second node. Something that I didn't mention earlier is that both my sync gateway nodes have got the exact identical configurations. Both have been configured with two replications, the exact same replications. I do not have to decide how to distribute the replications. I do not have to choose which replicator runs on which sync gateway nodes. Sync gateway is going to automatically distribute and load balance the replications across all the participating sync gateway nodes. So in this case, both the replications are participating in, both the sync gateway nodes are participating in replication. I've got two replicators configured on each of the nodes. So I've got one running on each of the nodes. So if I make the same call on the second node, on the second sync gateway node, notice that the first one says that it's not local, and the push-pull replication is running locally. Okay. So I'm going to start the replication. Over here, I'm going to start the push-pull replication. Remember again that there's no data on my local sync gateway node, on my local Couchbase server node, sorry. The data is just on the remote stores bucket. So I'm going to just start the replication, and then we can monitor it. Let's get rid of some of these things. So I have a way of monitoring this. And let's see over here, notice that there are some filter parameters. I'm calling this API on sync gateway 1, and I'm saying just get me the replications, active replications that are running on my local node. If I were to say false, so notice that the push-pull replication was scheduled to run on the second sync gateway node. And so now it's going to, it is pushing and pulling. So you get the stats. And if we were to go to the server node, you see that, it's pulling this data. There's a lot of activity going on here, but you can also go, I'm going to scroll all the way down, and you should be able to see a bunch of stats for sync gateway replications as well. So there's a whole bunch of stuff. There's data push, there's data pulled, and errors and so on. So you see that the stats are getting updated. Just to right now, the data is getting pulled, and this, remember, this is running on sync gateway 2. So I'm going to stop sync gateway 2. Okay, right here in the middle of a replication. So I've just stopped sync gateway 2. Replication, the push-pull replication was running on sync gateway 2. Now let's look at what's going on here. And I'm going to go and fetch the replications. Notice that the first replicator is still in stop state. The second one that was running is now scheduled to run on this node, and it is now on running state. In fact, if I were to go and fetch the status, so in fact, I can say only is true. You notice that both these replications are now running on sync gateway 1, and it just picks up from where the previous replication left off. You notice that it's just pulling documents. There's no documents being written because the local bucket was empty. I'm going to go and just update one of the documents in the local bucket. I'm going to go update the order data and just say one. Okay. So save, just to see that all this is happening in real time. So you see that there is a document that's written, that is document 1, and then there's also delta, which is sent. So it is using delta sync, and I've actually sent out. So that is a pretty big document, and I just changed one parameter of the document, one property of the document. So during delta sync, it's going to send just that parameter with some small, a little bit of meta information that will allow the receiving endpoint to patch that delta onto a known ancestor. So it's going to, so you can imagine if you're sending like hundreds and thousands and millions of these documents, and a lot of them have got just few attributes that are being changed, this is going to be significant savings in a network bandwidth. So again, if I were to start the replications, not start the replication, sorry. If I'm going to start the sync gateway 2, you should see that it's going to automatically be rebalanced to sync gateway then 2 as well. So let's see. So you see the second, that replication, because I have this flag which says local only is true. If I were to say false, you'll see that the other one was there on the second node. So in fact, if you go here, fetch the definitions, this is on the second sync gateway node, you notice that the push-pull replication is running, and it is on the local node. And of course, the other pull-only replication is scheduled on the other node. So at any point, the advantage now, you, in addition to starting the replication, you have the option of stopping the replications. You can stop push-pull replication, or stop any replication. You also have other actions. You can reset a replication. So you can actually, let's say you've gotten into a state where sync is not happening, you can resync everything from start, and you can use the reset action. So over here, I'm going to just stop the replication right now. And then that gives me the advantage of it gave me the flexibility of restarting it at any point. So I'm going to now switch back to the slides. So to wrap things up, the paradigm of edge computing is growing in relevance, and it complements the edge computing paradigm. So as enterprises are starting to look at distributed cloud architectures to meet their edge computing needs and the demands of their edge computing applications, Couchbase's intersync gateway replication technology would be a key enabler of such use cases. Once again, here are some related sessions at Connect that will go deeper into the related concepts and into the sync gateway. There is an advanced topic on that as well. And I'd like to leave you with some helpful resources where you can find more information. You can download Sync Gateway today and try out the new sync technology. We have extensive documentation that should help you along the way. A lot of these concepts that I've explained are explained in great detail in the documentation as well. And with that, thanks for watching, and enjoy the rest of Connect Online 2020. Thank you.